So in the interest of time, I will do the introduction, okay? Hey everyone, welcome to Data Umbrella's webinar for April. I'm going to do a quick introduction, about 5 minutes. Will do his talk, and we will open it up for Q&A. We request that the questions you ask are on topic, please, for this, which is GraphQL. This is being recorded, and it will be available on YouTube within a day. Data Umbrella is a community for underrepresented persons in data science, and we are a nonprofit organization. Beryl, who was just online, is having some tech issues. She's a statistician and data scientist who is based in Nairobi, Kenya, and she is an organizer for Data Umbrella. And you can find Beryl on Twitter, LinkedIn, and GitHub as Beryl Kanali. We have a code of conduct, and we thank you for helping to make this a welcoming, friendly, professional community for all. There are various ways that you can support Data Umbrella. The first and foremost is to contribute to making our space welcoming and collaborative. Other ways is to join our Discord server. The link is on our website. You can ask or answer general questions there and share events and jobs. Other ways that you can support Data Umbrella is to donate to our nonprofit. We are an open collective, and if you work for a company that is on Benevity, if you make a donation, your company will match that donation, and that helps cover our operational costs. We put all of our webinars on YouTube, and so this is just a sampling of them, and I will share the link in the chat as well. We have a lot of playlists on YouTube. One of them is career advice, which is quite a popular topic. And this is other playlists such as data visualization, data science for beginners, contributing to open source, scikit-learn Sprint, PyMC series, and NumPy series. We also have a monthly newsletter, and we're on dataumbrella.substack.com. So if you sign up, we aim to get the newsletter out for the first of the month, and we promise not to spam you or sell your email address to anybody. Our website has a lot of resources as well on accessibility and responsibility and inclusive language. We encourage you to check them out. We are on Twitter, LinkedIn, and all other platforms as Data Umbrella. Meetup is the place to join to find out about upcoming events. And we also have a really nice blog too. The platform we're using is Big Marker, and on the very top there are 2 letters called CC for closed captioning, so you can turn that on to see the live transcript for this session as well. Our next sessions are May 10th, Intro to PyTorch, also scaling up with Lightning Light. Sorry for the New York sirens. And May 24th, we have a Contributing to SciPy event, which is not yet posted on Meetup, but if that interests you, please block that on your calendar. Today's talk is Intro to GraphQL for data scientists. Will Lyon is a developer relations engineer at Neo4j, the open source graph database where he helps developers and data scientists be successful with graphs. He is the author of the book Full Stack GraphQL, published by Manning, and holds a master's degree in computer science from the University of Montana. And you can find Will on LinkedIn and Twitter at LionWJ. And you know, if you want to tweet about this event, we would appreciate that. We're on Twitter at Data Umbrella. And excuse me, and I will share the link to that in the chat as well. And with that, I will hand over the microphone and camera to Will. And if you have any questions, just post them on the chat. We will get them answered when it's a good time to stop for questions.
Great. Hey, everyone. Thanks for joining today. Like Reshama said, my name is Will, and I work for a company called Neo4j. Let's see, can everyone see my screen? Am I sharing that?
Not yet. I think you have to reshare it because I was sharing it.
Ah, okay. Resume, resume.
We can see it now.
Okay, great. Yeah, so the slides are available at dev.nefj.com/GraphQL-data-science. I also dropped a link in the chat. We have a little bit of sort of intro material in the slides, and then probably most of the session will be demo, and that is available on GitHub, which is also linked in the slides. So slides are probably the best place to start, but I'll share the GitHub repo when we get to that point. So like Reshama said, I work for Neo4j. We'll talk a little bit about Neo4j when we get to sort of a section in the demo where we're going to be working with some data that comes in from GraphQL. But really, I guess what I want to point out is that I'm not a data scientist. I come from more of a full stack developer background. So just for context, that might be helpful. Yeah, so the best way to get a hold of me is probably on Twitter, LionWJ, or also publish a blog at lionwj.com. Before we get in, I do want to mention that Neo4j is hiring for lots of different positions. Definitely check out the careers page. But one I want to mention in particular is the data science advocate role at Neo4j. So this is on my team, the developer relations team. And really what this person will do is work with the data science community to help them be successful with using tools like Neo4j in their data science workflows. So if that sounds interesting, feel free to ping me. I can give you some more details, or check out the careers page at Neo4j for lots of other really interesting roles as well. Okay, so like we said, the title for the session today is an introduction to GraphQL for data scientists. I think this will be interesting because we typically think of, and you typically hear about GraphQL in the context of application development, building web apps, mobile apps, this kind of thing, and maybe not so much, at least in the data science area. So I want to talk a little bit about, at a high level, kind of what is GraphQL, and then why is it interesting for data scientists. And I think there's two ways to come at this for sort of the relevancy of GraphQL for data scientists. And that's really, one is using GraphQL as a data source. So pulling data through a GraphQL API as a source for some of my data science workflow. And then the other aspect that I think GraphQL is relevant for data scientists is to sort of share the results of a data science workflow, or I like to call this sort of operationalizing the results of data science. So can I build a GraphQL API that exposes some data from my data science workflow? So we're going to go through this today in the demo section. We're going to pull data from the Meetup GraphQL API. We'll load it into Neo4j, do some basic graph data science work with that, and then we'll build a GraphQL API to expose the results of our workflow, which will basically be like a Meetup group recommender system. So that's the plan. As you have questions as they come up, feel free to drop them in the chat. I can see the chat over here. So definitely just let us know in the chat as your questions come up, and we will definitely dig into them. Cool. So first thing we should do is talk a bit about GraphQL at a high level, kind of what it is, what are some general advantages and challenges that come up when we're using GraphQL. So at a high level, GraphQL is an API query language and a runtime for fulfilling these queries. So basically, it's a query language for APIs. So with GraphQL, we have a strict type system. So we define what data is available in the API. So what are the entities, what are the attributes? These are called fields and types in GraphQL terms. And how are they connected? And this is where the graph part of GraphQL comes in, and that's the connection between the types or the entities in our GraphQL API. So in this simple example here, this comes from the graphql.org site. They're defining a type for a project that has name, tagline, and contributors. And the contributors field is actually referring to another type. It's referring to a list of user types. So that's defining this relationship from the project to the user. They are contributors. So that's where the graph piece of GraphQL comes in. As part of that type system, as part of those type definitions for our API, we also specify the entry points. So when I'm querying the GraphQL API, can I search for, in this case, projects? Can I search for users? These sorts of things are all specified in the type definitions for the GraphQL API. So let's talk about a few concepts in GraphQL that are important. One is this idea of type definition. So where we are defining the data that is available in the GraphQL API. Typically, we use what's called the GraphQL Schema Definition Language, or SDL, to define these, although there are other ways of programmatically defining these. And I should say that we can build GraphQL APIs in pretty much any backend language, although GraphQL sort of grew out of the JavaScript ecosystem. So this schema definition language, this SDL, is a nice language agnostic way of defining these types that don't depend on using code in whatever language I'm building my GraphQL API in. So the basic idea here is we define types. So these are the entities in the API that I want the consumer of my API to be able to work with. And then types have fields. So here we have a movie type. It has title, and we specify the type of the field. So title is going to be a string, year is going to be an integer, and so on. And then when we get down to genres, that's referencing another type. So we're defining a relationship there between movie and genres. Now, when it comes to querying a GraphQL API, there are a few different operations that we can work with. Today, we'll mostly be looking at queries, which are read-only operations where we're asking the API to return some data. But there are mutations, which are write operations, and subscriptions, which are for like fetching events, kind of like GraphQL's built-in pub/sub functionality. So here's an example of a query operation. We are first specifying the entry point and any arguments for our operation. So in this case, we're starting with the movies entry point. There are, if we look at the type definitions for a GraphQL API, we'll see three special types: the query type, the mutation type, and the subscription type. We're going to ignore mutation subscription today, so just the query type. So the fields on the query type then become the entry points. So this API has a movies entry point that takes some arguments. These can be for things like filtering or pagination. And in this case, we're passing where the title is River Runs Through It. So we're filtering for a specific movie at this top level operation. Then the rest of the GraphQL query is what's called the selection set. And the selection set is this sort of nested structure that is doing two things. One, it's describing a traversal through the data graph. So at each layer of nesting, so here we're starting with title, then we go to actors, and then actors is another type. So there are multiple fields on the actors type that we can then sort of nest through to select. So we're saying bring back the name field on the actor and so on. So you can think of this selection set as kind of like describing this traversal through the data graph and also explicitly specifying what fields to be returned in the query. So this is one important concept in GraphQL, that the client is able to select what data is returned from a query. Unlike, say, a REST API where we request a maybe like movie resource and we get back all of the fields on a movie. With GraphQL, we specify just the fields that we want to be returned. And then the response, so on the right side, this is the JSON object, which is the response to this GraphQL query. And we can see that the shape of the response matches the selection set of the query. So we're getting back exactly the data that we asked for and nothing else. So we've talked about sort of some concepts that are relevant for querying GraphQL APIs. We talked about this idea of a selection set and the special entry points on the query type. When it comes to building GraphQL APIs, basically what we're doing is taking the type definitions that define the schema for our GraphQL API, and then we have to create these things called resolver functions, which are functions that have the logic for actually going out to the data layer to resolve the request, to maybe search a database for some information. We can even wrap other APIs. So GraphQL is really data layer agnostic. We can build GraphQL APIs really on top of any database, data layer, other APIs, and so on. It's really just a matter of how we want to construct these resolver functions. Now, there are a few problems that can arise when we build these resolver functions. So this example here is using, this is from a conference session GraphQL API. And we can see the query field. So this has a field called session on the query type. So that's our single entry point. So the only thing we can do with this GraphQL API is search for sessions. And in the resolver function, we're going out to a database to search for sessions by some search string. And then for each session that we find, we can look up the room, we can look up the theme, or we can find recommended sessions. And each one of these functions, this is using like a database ORM sort of API. But for each one of these fields on the session type, we now are going back to the data layer to ask for more information. So you can see that because of the way this is called in a nested fashion, if we start with searching by session search string and we end up with, say, 10 sessions that match the result, if we also ask for room, theme, and recommended, we're going to make 3 trips back to the database for each one of those sessions that we found. So this problem that comes up is called the N+1 query problem, which forces us to be a bit more optimized in the way that we're building GraphQL backends, because with making those N+1 round trips to the database, that can introduce some performance hits. So there are a few ways to get around this. One is to use database tooling that can generate database queries from GraphQL queries, which is what we'll look at later on today when we start looking at the Neo4j GraphQL library. Anyway, wanted to just point out this idea of resolver functions and some of the issues that come up. This is sort of a key component when it comes time to build GraphQL APIs. So what are some of the common benefits of GraphQL? Well, really the reason that GraphQL was created, and GraphQL was created in Facebook. I think they started using it internally in 2012 and then open sourced it in 2015 or 2016. But really the sort of key reasons GraphQL was created was to solve this overfetching and underfetching query and the performance problems that came with that. So overfetching is sending more data to the client than what the client needs to, say, render the view in an application. So originally GraphQL was used for Facebook's news feed, and for the news feed, you don't need to render all of the content of a post or all of the information about a user. You only need like the title of the post, maybe the user's avatar, and maybe their screen name. And because we're in this case talking about mobile devices, it can be kind of expensive to send more data over the network than what is required to render the view. Then this idea of underfetching, well, that means that if I'm rendering the news feed and I need to show a list of news items and I need to have some information maybe about the user associated with that, well, I want to make sure that I'm only making one request from my mobile device to the API endpoint to render everything I need, because mobile devices have maybe more network latency, that sort of thing. So this is where the idea of the client being able to specify in the selection set exactly the fields that are necessary to render the view, that's where that comes in. So those are sort of the key benefits of GraphQL. There are other benefits that come from that. So for example, we have a clear GraphQL specification, so we know exactly what is and isn't GraphQL. Being able to sort of attach some of our data fetching logic with our component-based interactions in the UI can be valuable for application developers. And then this idea of sort of thinking in graphs throughout the API and in our application, I think can be helpful as well. Because of the type definition and because of the type system that GraphQL has, we can also generate lots of interesting tooling, like generate documentation, generate things like autocomplete for queries in our developer tooling that can be very useful as well. Some of the challenges that come up, well, we talked about this idea of the n+1 query problem. We talked about this idea of the client being able to specify their traversals through the data graph, so we're sort of exposing arbitrary complexity to the client. So we need to think about how we handle performance considerations in that case. And I think generally the most common challenges when you are building a GraphQL API are that a lot of the well understood practices from the REST world don't apply. So things like HTTP status codes, error handling, caching, all this is handled a bit differently. There are best practices and tooling that address a lot of these issues, but just be aware that it may be different from how you're familiar with sort of the REST world of doing things. So I mentioned that because we have type definitions, there is some interesting tooling that we can generate using GraphQL. So GraphQL has this feature called introspection. So what that means is that I can ask a GraphQL API through a GraphQL query to tell me about the types, the fields, how the types are connected. All of that information is called the introspection query. And with that introspection feature, there's some really interesting tooling that's emerged in the GraphQL ecosystem that does things like generate documentation. So it's commonly said that GraphQL APIs are self-documenting because I can introspect the GraphQL API and it can tell me exactly what are the entry points, exactly what fields are available, and I don't have to rely on possibly outdated documentation because this is coming directly from the GraphQL API. So this introspection feature is really powerful, and lots of tooling, both in our development environments and also separate tooling has emerged to take advantage of that introspection feature. So one of the tools we'll be using today is GraphQL Playground. GraphQL Playground runs in a web browser and will run the introspection query and then show us the generated documentation. And it also allows us to write GraphQL queries and view the results. And it takes advantage of that introspection functionality to give us things like autocomplete, syntax highlighting when we have some errors in our GraphQL query, and so on. So this is a tool that we will be using today. Okay, great. So that's all the slides that I have for the introduction piece of this. So now we're going to switch to more of a demo, looking at a couple examples. And again, feel free to ask questions in the chat as they come up. I'll be sure to get to those.
Will, there's a question in the Q&A. What is the default behavior if a query includes a non-existent field?
Oh, great. That's a good one. So if you include a field on a type that does not exist in the selection set, you'll receive a couple of errors. One is there can be some client-side checking. So depending on what client you're using to send that GraphQL query, so like, for example, if we were using, let me go back a slide. If we're using GraphQL Playground, we'll get a red squiggle here that says, hey, that field doesn't exist on the movies type. And then if we send that query to the server will give us an error and say that field is not available on the type. So we want to definitely take advantage of some of that tooling to catch those sort of errors before they hit the server. Also, depending again on if we're using like the VS Code integration for GraphQL, we can have those sorts of errors pop up in our development environment as well. Great. So we're going to switch to looking at some code and some examples. So there is a GitHub repo, which I don't want to save. I want to copy link address. So I'll drop a link to this in the chat. So this is a GitHub repo that has a few things that we are going to look at. Here's the README for what this looks like. The first thing I'd like to do is take a look at a GraphQL API that's out there running using GraphQL Playground and try to answer some questions with these GraphQL queries. And then we're going to look at querying GraphQL using some Python tooling. So there's a Jupyter notebook that we're going to walk through that shows how to query data from the Meetup API using GraphQL. And then we're going to load that into Neo4j to do some graph data science and see how we can then expose the results of that to build a Meetup group recommender using GraphQL and Neo4j. And then if we have time, which I don't think we will, there's also some graph data visualization where we can use GraphQL as kind of the language for fetching data for visualization tooling. So with that, let's take a look at GraphQL Playground. So we went through the slides. I'm going to open up this movies.neo4j-graphql.com. I'll drop a link to that in the chat too if folks want to play along at home. So the first thing that we'll see is this query was in here. I already wrote this query, so that's why it popped up in there. But our goal here is to just get some familiarity with GraphQL Playground, how we use it to write GraphQL queries and view the documentation. So the first thing we're going to do is click on this Docs tab. And this Docs tab, this is taking advantage of that introspection feature that I mentioned earlier, that is asking this GraphQL API that's running, hey, what are the entry points for the API? What data is available? How is that data connected? So I can see that I can start by searching for movies. I can see the fields that are available on movie. I can see how movie is connected to other types like the actor. And I can see what are the arguments. So for example, the where argument, this allows me to do filtering on that movie's entry point. The options allow me to do things like pagination, sorting, limiting, this sort of thing. So let's take this first query here that is an example, and we'll paste that in. So this is searching for movies, sorting by title in ascending order, and limiting to just give me the first 10. So I just get the title. And I can see that as I add fields, I get this tab completion to show me exactly what fields are available. So we can add plot, and we can define more complex traversals as well. For now, we want to search for actors and the name of the actors as well. Here's another example. So now searching for a specific movie, Jurassic Park. So we're filtering where the title is Jurassic Park, then give me the title, actors, and name of each actor. And next question is, what are the genres of Jurassic Park? So we see here how we can filter for a specific movie, traverse to actors, and now we want to know what are the genres of Jurassic Park. So to figure that out, we'll look at the Docs tab, go to our movies entry point, and if we look down here in the fields for movie, we can see that we have genres field, which is a array or list of genre objects. And on the genre, we have name. So this means that I can add a field to the selection set here called genres and ask for the name. And now I'll get the genres for Jurassic Park as well. And the next question is, what other movies are in those genres? Well, to figure that out, we can go to our docs and we're looking at genre, and you can see that from the genre type, well, we can traverse to movies. So let's do that. So for each of our genres for Jurassic Park, we want to know what are other movies that have the same genre. So that's going to be the movies field. But we don't want to return every single movie. There's probably thousands of thriller movies out there. So we're going to add an options. And here's where our autocomplete comes in handy. I can do a control space and see that I can do a limit for 10. So this will give us up to 10 movies for each genre of Jurassic Park. So here's, let's see, 10 thriller movies, 10 sci-fi movies, and so on. So that's a brief look at GraphQL Playground, which is really handy for exploring a GraphQL API that maybe you haven't seen before, to explore the documentation, to construct these queries, and look at the results. There are similar tools to GraphQL Playground out there. Graphical is one, and Apollo Studio or Apollo Sandbox is another one. We'll see an example of Apollo Studio later on. So when we're working with data, and we want to fetch data from a GraphQL API, we can use tools like GraphQL Playground as kind of an exploratory way to approach that. But another option is programmatically. So if we're building an application, or if we're doing some data science work, we're probably working in Python. So I thought it would be interesting to take a look at how can we treat GraphQL as a data source for data science workflows using Python. So there's a Jupyter notebook linked here. There's a Google Colab is linked for this. I think I was just testing it in Google Colab this morning, and there's an issue with the async event loop in Colab that doesn't quite like one of my examples. So I'm going to go through this in Jupyter, and we'll fix the Colab issue. But this notebook is in that GitHub repo in notebooks meetup.ipynd if you want to follow along there. So let's take a look now at how can we pull data in to, in this case, a Python notebook as a sort of source for our data science activities. We're going to look at the Meetup API. So Meetup has a GraphQL API. I think this is a recent migration from their REST API. And let's see, where's a good place to start? A good place to start, I think, is this guide to the Meetup GraphQL API if you're starting to look at the docs for this. They do publish the schema as well. So you can see the queries. These are all the entry points. And then also they publish docs for what objects are available as well. To use the Meetup API, you need to have a token. So Meetup uses the OAuth authorization flow. So I put some instructions in here for how to grab the token. What you really need to do is follow these steps in the Meetup docs and basically create a new client. I think it's called a client app is the terminology that Meetup uses, and then wait for Meetup to approve that. And then you can go through the OAuth flow to generate a token. There's also someone built this app called the 1 hour token, which you can sign into with your own Meetup credentials. Just be aware that this is not an official Meetup app, and that some third-party developer who created this will get access to your basic Meetup information, which is like your name, maybe email, something like that. So that's what I did. That's one option, just to generate a token. So one thing we may not have mentioned is that by default, GraphQL uses HTTP. So by default, a GraphQL request is an HTTP post operation. And in the case of the Meetup API, they use a bearer token as an authorization header for authorization. So for each request to the Meetup API, you'll need to add this authorization header with your token. We're going to use the GQL Python GraphQL client, which can handle that for us. So the first thing we need to do is get our Meetup token. I think the setup to do that takes a little bit of time, especially with getting the client app approved. So I'm just going to go through this, and later on, folks can work through this from home. I set my Meetup token as an environment variable. So I'm going to read that from my environment variables. There's also, if you're using Google Colab, there's a Colab env package that allows you to create a file in Google Drive with your environment variables and then read that in Google Colab. So this is optionally set up if you're using Google Colab as one option to read from Google Drive. I hadn't seen Colab env package before. Is that, I'm curious to know if that's something folks are using, but it seemed pretty handy. Okay, so the first thing we're going to do is from GQL, which is this Python package for working with GraphQL requests. Oh, and by the way, I've already installed these, but here's the dependencies up above at the beginning that we're going to install: GQL, Neo4j driver package, and if you're using Colab, this Colab env package. So the first thing we're going to do is import what we need from this GQL package. We're going to set up our transport layer for our GraphQL endpoint, and there's two components to that. One is the URL for the GraphQL endpoint, and then in our case, the authorization headers that we're going to set. So it's always going to be the same: GraphQL endpoint api.meetup.com/GQL, and the headers, every request we want to add our authorization header with our Meetup token. Then we're going to create a client that is using this transport layer that we've defined above. And this is something interesting that I found with the Meetup API. So I said earlier that a really neat feature of GraphQL is this idea of introspection. So I can ask the GraphQL API, hey, tell me all of your types and data and how they're connected and so on. Well, GraphQL APIs can disable that feature. Sometimes that's not something that you want to expose in production. And so it seems the Meetup API has disabled introspection. So with the Meetup API, we don't have the advantages of some of that tooling that we can use with GraphQL introspection. And so the GQL client will try, when we first connect to it, to run the introspection query so that it can give us things like autocomplete and client-side syntax checking, those sorts of things. But we need to turn that off because the Meetup API has disabled that. So we'll have to rely on the Meetup API docs to figure out what data we're working with. Then we're going to run just a simple GraphQL query. So we're starting with the self endpoint, which is going to give me the currently authenticated user, which will be me, and then the ID and name field on the user. So if we look in the docs under queries, this is the one we're going to start with, self, which gives me a user. So if we look at the user type, then we can see the fields that are available on the user type. So let's run that. And we should see that I am the currently authenticated user. If you're following along, you should see that you are the authenticated user. And yep, and we get back an object with my ID and name. Great. So now let's search for the data umbrella Meetup group. And for these queries, I think it's often helpful, because we're thinking in terms of graphs with GraphQL. I think it's helpful to sort of visually think of what we're trying to query for here. So we want to start with group. So there's an entry point. If we search in the Meetup API docs and under queries, we have keyword search. So, oh no, that's not the one we're doing. Group by URL name. This one, group by URL name. That takes a required argument that is the URL name. So we're going to search for data umbrella, and then once we find that group, in our selection set, we're going to pull back the ID, name, the link, but then also we want to traverse out to the topics connected to the data umbrella meetup group. So I think it's helpful to sort of think of visually the query we're trying to construct using GraphQL. And this will take a moment, but we get back the ID of the data umbrella group, the name, its URL, and then the topics associated with that. So business analytics, artificial intelligence, data science, Python, and so on. Let's add to our selection set, and now let's search for upcoming events, including who's hosting the event. So here's the graph representation of this query that we want to construct. And here you'll see something kind of interesting, which is the result of this upcoming events field. You can see here that there's a count field, but then something called edges and then node. So let's run this and then see if we can parse what's going on there with this upcoming events field. While that's loading, we'll just talk about that. So this upcoming events field, and if we look at the docs, we can see this. So we're doing group by URL name. And then on the group, we're searching for upcoming events, past events, which gives us upcoming events connection. And this is what's called a relay style connection type. So I think this is one of the more confusing aspects, at least for me, when you're getting started with GraphQL to see this. So this is just a different way of representing connections or relationships in GraphQL. So for example, here, when we had topics, so topics, that's another type, another object. So we have this relationship from the group to the topic. And that's just represented as sort of a simple list of topic objects. But there can be cases where we have metadata about the relationships, or if we want to enable things like cursor-based pagination, then that's where this connection type can come in handy. So think of the connection type as kind of like a wrapper around relationships in our GraphQL API. So instead of just giving us the events, we have this connection, upcoming events connection type that's wrapping the edges. But this is useful because we can do things like see the count of the, so the total number of events, and page info, which allows us to do pagination. So anyway, that's why we need to traverse down to the edges, which represent the actual relationship. So this upcoming event relationship here, and then the node is going to be the event node itself. And then you can see we can do a nested selection on the event node to find the host of those as well. So here we can see the upcoming events. We have Intro to GraphQL for Data Scientists, which is the current event. And then we have Introduction to PyTorch coming up next. We can construct more complex queries, such as who RSVP'd for an event. So here we're looking at the specific event by ID and looking for users who have RSVP'd. We can search for groups by keyword. I'm going to move through this section a little more quickly because I want to show something else we can do with the result of this data. But these are interesting examples to look at. So if we want to search for groups by keyword, we have a keyword search that takes a filter argument, and the filter argument has our query. So imagine if we're on meetup.com and we're typing into the search box, I want to search for data science groups or something like that. We need to specify a location. The lat and long are required fields. This is roughly San Francisco. So what are the data groups in the San Francisco area? one thing that's interesting here is this, the 3 dots on group and then the selection set within that. This is called an inline fragment. And this is a way of dealing with some of the abstract types in GraphQL. So we said that we can define types, so things like groups, events, those are types. But oftentimes when we have search results, we may have a field that we want to search for maybe both groups and events. So because we have the strict type system in GraphQL, we would then create what's called a union type. So a combination of group and event where the concrete type is either a group or an event, but we have some union type above that, which is sort of a placeholder for either a group or an event, if that makes sense. And so this inline fragment allows us to define the selection set for, in the case that we found a group, or, and I haven't included it here because we're only just searching for groups, but we could add a selection set for what happens when we get an event, which may have a different set of fields that we'd like to select. So here we can see, I'm also pulling in the number of past events and the topics for any of these groups. So we find 20-some groups here, the number of past events that they've hosted, and then some topics associated with those events. And this is all for data-related meetups in the Bay Area. So one thing that we want to look at now is, okay, so I've seen how to write some GraphQL queries using Python. I now have basically objects, dicts or list of dicts to work with in Python. What are some things that I can do with that? Well, really, we can think of this as a data source for our data science workflow, similar to other data sources. What are things we can do? Well, working with data in a DataFrame, that's a very common way to work with data in Python. So this example is just showing how we can load the result of this GraphQL query, so searching for our data-related meetup groups and their topics, and load that into a DataFrame. We do just some simple parsing of some of these columns here. So for example, past events for each group is an object, is a dictionary in Python, where the key is count and the value is, in this case, 3. So we need to format that a bit. Similar for the topics, we want to pull out just and end up with just a list of strings instead of a list of dictionaries. But that's really all that's necessary in this case to load that into a data frame. And then we may want to, say, plot the distribution of number of past events for each group. So we can see maybe which group has been around the longest or which is the most active. We can see clearly that this SF data science group has by far had the most users, or the most events rather. So what's something else we can do with our GraphQL data once we've pulled it into Python? Well, one thing we can do is load that into other tools as part of our data science workflow. And one of those might be Neo4j. So Neo4j, we said, is a graph database. There are lots of interesting things we can do with Neo4j. One of those things is we can use the graph data science functionality in Neo4j to run graph algorithms with Neo4j. And there's some instructions here that walk through using Neo4j Sandbox to work with data in Python. Maybe I'll just go through this in the notebook rather than following along since we're running short on time here. But the basic idea is using Neo4j Sandbox, we can spin up a free hosted Neo4j instance that is private to us, that sits around and allows us to load data, to write queries, visualization, and so on. I have a few standing already. The one we want, so we're going to load our own data, is the blank. I'm already running the blank. I might already be running the blank. Your own data. Where is the blank one? Blank. I think it's not letting me. Oh yes, I'm already running one. Okay, great. So I already have the blank Sandbox running. And what we'll do here is we can replace this with the connection credentials, use our, this is called the bolt URL, which is the endpoint that the Python driver for Neo4j uses to connect to Neo4j. And then we can run some Cypher queries. So Cypher is the query language that we use with Neo4j. So here we're just writing a simple query to search for the number of nodes in the database. If you're starting off, that should be 0. This one was 120 for mine. I think I had a database that already had some data. And then one thing we can do, because GraphQL, or the result of GraphQL is JSON or objects, dictionaries, an array of dictionaries in Python, we can pass that data as a parameter in Cypher to then create data in the database. So here we're going to iterate over each group that has groups as well as the topics associated with the group, create that in the database, and then create the relationships that represent the connection between the group and the topic. Neo4j has some visualization tooling built into it, so we can verify what we created using Neo4j Bloom, which is available in Sandbox, to explore that data visually. But oftentimes, it's helpful to use graph algorithms to help us interpret our visualization, or use visualization to interpret the results of graph algorithms. So here's a Cypher query that we're looking at the size of, for each group, the number of topics that it has. This is called degree centrality. And we're going to store that as a property on each node, which will then represent sort of the significance of the topic. So how many groups have that topic? And now we can change the visualization to make nodes that have, or topics that have lots of groups with that topic larger. For the size of the group, we're using the number of past events. So if you've had more events in the past, you're a more prominently sized node in the visualization. So that's one simple algorithm. We can also use this Neo4j Graph Data Science library to run more complex algorithms. In this case, we'll look at using the node similarity algorithm, which looks at the overlapping, in this case, topic nodes, to then add a relationship to the graph, this similar relationship connecting groups. And so what we'll see here is that groups that are similar, they have similar topics in common, they have a higher score on this similar relationship. So we run that, and that's now created in the graph. So we could query that in the graph to say, show me the most similar relationships. But we talked about this idea of using GraphQL to expose data, to expose the results of our graph data science workflow. And there's an example here. The code for this is in the GitHub repo. We can also launch this in Code Sandbox. I'd just like to show this example of how we do this. So this is JavaScript. This is a Node.js JavaScript tooling. I mentioned that a lot of the GraphQL tooling has evolved out of the JavaScript ecosystem. And here we're going to use the Neo4j GraphQL library to build a GraphQL API exposing the data that we created in our Neo4j instance. And to do this, we create some GraphQL type definitions, so that define, in this case, we have data about groups and topics. And we add this similar field that is exposing the similar group relationship that we added to the graph a minute ago. And this then will serve a GraphQL endpoint that will allow us to query for similar groups. This tool, so I mentioned earlier, there are a couple of flavors of GraphQL Playground, similar tooling like Graphical, and I said there's Apollo Studio is one of those. And this is the Apollo Studio example. So very similar, we can write queries here, see the results. We can look at the documentation in the Schema tab as well. Great, well, that is most of what I wanted to cover. We're out of time here, so I will just refer back to the GitHub repository that has the code and examples. And there's also a section on data visualization that we didn't get to with GraphQL, but I definitely encourage you to check that out in the GitHub repository. And that is all that I have for today.
Thank you so much, Will. I know you said you had a hard stop. You have a meeting to get to, right?
I do, yeah, unfortunately.
All right, well, thank you so much. And we will have the recording up and we'll be in touch.
Great. Thanks everyone for joining, and thanks Reshama for organizing, and Beryl.